Hey everybody, it's Mrs. Harbin and I'm here to talk to you about metallic bonding and acid nomenclature. Okay, so hopefully when we're done with this you can do all of these 6 things. Get going here. Section 5.6 will give you some background information and some more information, and so will pages 441 and 442. Okay, so what better time to get started than right now? Acids. What the heck is an acid? Well, acids are a certain kind of compound. We're going to spend a whole unit on it next semester. But right now, we got to be able to recognize. Recognize what? All of the things we're going to look at that are acids start with the element hydrogen. They have one thing in common, and that's hydrogen. Hydrogen is an element that has the symbol H. So I recognize acids by noticing that hello, they start with hydrogen. Hello, hydrogen. Okay. So, that acidic hydrogen is the hydrogen that's in the front of the compound. That's the thing that makes it an acid. We'll learn why next semester. But for now, you look for that H to recognize it's an acid. Okay? So, HCl, what kind of compound is it? Hello, it starts with hydrogen. It's an acid. Okay? HCl3. Hello, it starts with hydrogen. It's an acid. HClO2. Hello, it starts with hydrogen. It's an acid. So recognize the kind of compound it is. Once you recognize, look, they all start with H, so we can't call them something with hydrogen. We got to call them acids for another reason. Name them because they're all different, so they have to have different names. All right. So here's how you decide what to name an acid. First, you recognize, hello, hello. Then you look at the second part of the acid and decide what the anion ended in. Cl is chloride. S is sulfide, so it ends with ide. If the anion ends with ide, you use the prefix hydro and the ending ic acid to name the acid. So HCl, here's the Cl minus, so here's the chlor part, and here's your hydroic acid. HCl is hydrochloric acid. All right, hydroic acid, here's the compound. Hello, it starts with hydrogen, and then sulfur is what sulfur comes from. So hydrosulfuric acid. Hydroic acid is the part from the rule. Okay. Hello, I start with hydrogen. I'm an acid. So you look at the second part and they end in ite because SO3 is sulfite, NO2 negative is nitrite. So that's sulfite and nitrite. When you name that acid, you use the suffix OUS and the word acid to name it. Right? So SO3 negative 2 is sulfite, so it's called sulfurous acid is the ending. Look, no prefix. All right, nitrite is us acid, nitrous acid, no prefix. Right. Third kind of acid. Hello, I start with hydrogen, so I look at the second part. I have phosphate and chlorate. All right, so the ending of the anion is ate. So no prefix when you name the acid. You just put the ending ic acid on it. So phosphate turns into phosphoric acid, all right? And chlorate turns into chloric acid. Right? Look, no prefix on those, no prefix. It's just phosphoric acid and chloric acid. So you should put these rules into your notes and put some examples. And guess what we're going to do next? You got it, we're going to practice. All right, hey, look, what kind of compound is it? Hello, I start with hydrogen. Well, you must be an acid then. So I'm going to look at your second part, and I notice that it's S, but I know S is a -2 charged and it's called sulfide. So then I'd use hydrosulfuric acid to name you. Hydrosulfuric acid. Hello, I'm hydrogen. I start with hydrogen. It must be an acid. All right, so SO4 is the anion part, and we know it's a -2 charge. That's sulfate. Okay, 8 turns into sulfuric acid. All right, so ide, hydroic acid, 8 is ic acid. Hello, I start with hydrogen, so it must be an acid. So I write down the second part is sulfite. And so ite turns into us acid and sulfurous acid. Us acid. So I made up a little song to help you remember. It goes like this. Hello, I'm an acid. I start with hydrogen. And once you recognize, then you're ready to begin. look at my anion, find out if it's 8 us or ide, and then use the prefix and ending that you can use. So here we go. I ate it, it was icky, and then I got the itis. I'd use hydro-ick, yeah, I'd use hydro-ick. I ate it, it was icky, and then I got the itis. I'd use hydro-ick, yeah, I'd use hydro-ick. So, hello, I'm an acid. I start with hydrogen, and once you recognize, then you're ready to begin. I ate it, it was icky, and then I got the itis. I'd use hydro-ick, yeah, I'd use hydro-ick. It's a fun song to sing, try it. Hey, look, these are acids. How do I know? Well, look, it says the word acid right there in the name. All right, calm down, Harbin. So, if it ends in the word acid, you know it's going to start with H+. H+, hydrogen is a +1 charge. So, now I need to deconstruct. It says hydro, and it says ick. So, that means this nitr part came from ide. So, it's nitride, because ide came from hydro-ick, or ick. Hydro-ick is from ide. So then I would do nitride, it means periodic table, group 5A, -3, and then that doesn't equal 0, that doesn't equal 0, that equals 0, H3N for the chemical formula of hydronitric acid. Alright, it says acid. I'm going to put H+ because I know it's H+. Now, ick acid came from nitrate. I ate it, it was icky. Ick acid ate, I ate it, it was icky. So I need NO3 negative because I memorized nitrates, formula and charge. Then I have to make it equal 0. That already equals 0, HNO3. Okay, this is an acid. Hello, I start with hydrogen. So this ends in us acid. It must have come from nitrite because itis. I got sick when I ate it. It was icky, so I got sick, itis. Okay. NO2 negative. That and that equals 0, so I can put them together. HNO2 is the chemical formula for nitrous acid. Okay, so that's it. That's one main idea in this PowerPoint is recognizing, writing names of acids, and writing chemical formulas for acids. So the second thing is properties of metals. We talked about ionic compounds. We talked about covalent compounds. But what holds gold together? And what holds steel together? And what holds silver together? It's called metallic bonding. Metallic bonding, metals have variable bond strengths, okay? They have variable melting and boiling points, but mostly high because things like iron melts at a higher temperature and silver and gold, but like gallium melts in your hand and mercury's already a metal, already a liquid. So what do you know about metals? Hopefully you know they're good conductors of heat and electricity, they're malleable, and they're shiny. Those are things you should know about metals, and we're going to talk about why. The model of metallic bonding is one where we think that these metals are held together not to make compounds, but by a kind of bond called metallic bond. And so all of the metal ions, so here's aluminum, and it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total electrons around it, so it's aluminum ion. All right, aluminum cation. So what about aluminum's other 3 electrons? Well, they're all over the place in this model. Okay, here's another aluminum cation. And where are its valence electrons? Well, maybe it's those 3. Okay, here's another aluminum cation. Where are its valence electrons? Maybe it's 1, 2, those 3. Here's another metal, aluminum ion. And here's all of its valence electrons. So here's what I want you to see. That in metals, the metal cations line up in a format, and then what holds them together are all of the valence electrons of all the other metal ions plus its own are held together, making this C of electrons. Okay, I call it non-directional covalent bonding because all of these cations are sharing the valence electrons of all the other metal ions. Okay, so how does this model of metallic bonding explain properties of metals? Let's see. It says that this is just a picture showing all of the valence electrons around gold cations. Okay. So what do we know? We know that metals conduct electricity. How can that be? Well, if you apply electric current, then those valence electrons, because they're not trapped anywhere, they can move through the metal. Okay, they can move and push electric current through the metal. So the sea of electrons causes them to conduct electricity. What about heat? Well, you add heat to a metal, then the metal valence electrons shared by everybody, everywhere, can push heat through a metal. So it conducts heat, conducts electricity, conducts heat, those sea of electrons. That sea, or all of those valence electrons, can move through the metal structure. What about malleability? Well, if I put the hammer down, okay, over here, oh look, this looks like a hammer. Oh, it's a horrible hammer. Anyway, I hit it, so you still have those metal cations, but when you hit it, the valence electrons can adjust a little bit and keep it from breaking into pieces because the adjustment of the sea of electrons. So metals are malleable because they have a sea of electrons. Metals conduct heat and electricity because of the sea of electrons. Okay, so that's how we explain properties of metals. There's one more I'll show you in a little bit. So this is what we learned in this unit, ionic bonding. First day we found brittle solid crystals. The repeating pattern of positive and negative, and positive and negative, and positive and negative ions is what we believe the structure of ionic compounds looks like. They do not conduct as solid because those ions are stuck in place. They dissolve in water because water can surround each ion because water is polar. They conduct electricity when dissolved because once it's dissolved in water, oh look, a little water molecule, okay, little water molecules, then these ions can move throughout the liquid once it's dissolved. So what happens to electrons in ionic bonding? They get transferred from the cation to the anion. How is that different than metals? Well, we know metals are shiny, malleable, mostly solid except for mercury. So their atoms turn into cation, but their valence electrons are used by everybody, shared by everybody, used by everybody. Okay, so that's what we say. So the electrons get shared in not in one direction, but in all directions by all of the metal cations. So that mobile sea of electrons allows them to conduct as solids. It also means they don't really dissolve in water because there's not opposite parts that water can pull apart. Okay, so ionic and metallic bonding helps us explain properties of ionic compounds and metallic compounds. So what about all of it put together? Please make sure the 3 kinds of bonding that you understand how and why things are the way they are. So metallic bonding is made of 2 metals. There's that non-directional sharing of those valence electrons. They conduct as solid and liquid. They have high, low, and medium melting points, but a lot of them are high. They don't dissolve in water, and they have variable bond strength. Covalent bonding are the 2 nonmetals. The valence electrons are shared and stuck between atoms. So here's an example. These 2 electrons are shared, but they're stuck between H and H, so they will never conduct electricity. Okay, these valence electrons, everybody can have them anytime, so electric current can flow through. Covalent bonding could have high, low, or medium melting points, but they are the only ones with low melting points. If you have polar molecules, they can dissolve in water, but nonpolar things won't. They might have low melting and boiling points because they have low intermolecular forces. Okay. Ionic bonding, metal and a nonmetal. The electrons are transferred from the metal ion to the nonmetal ion. Okay. They conduct as liquid or solid conduct when their liquids are dissolved, but not as solid. Do not conduct as solid. All right. Do not conduct as solid. No. Okay. But they do conduct as liquid or aqueous. They have the highest melting points. Many of them are soluble in water, and they have high bonding strength. All right, so we learned a lot. Look at these models. Which one's ionic bonding? This one. All right, solid crystals, positive and negative ions. You hit it with a hammer, you push a positive next to a positive, and it shatters on those lines and breaks, and that's why it's brittle. Okay, they do not conduct when they're solid because these are stuck in place. But once you melt them or put them in water, those can move. Okay, metallic bonding. See that sea of electrons? You shine light on it, the light shines back. Reflective. Okay, shiny, 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 shiny. Conduct electricity. Those electrons can flow through. Valence electrons, sea of electrons. All right, so that's the model for metallic bonding. Model for covalent bonding. You have the sugar stuff, you have this water stuff, you have some honey, you have some gas. Covalent bonding, electrons are shared between 2 atoms to make molecules. But those molecules can be polar, so that they dissolve in water, or they can be nonpolar, so that they don't dissolve in water. But what happens is electrons are shared between 2 atoms. So what should you know? Okay, you should know what type of bond is made of 2 metals is metallic bond. What type of bond conducts as solid? Metallic bond. What kind of bond has low melting point? Usually covalent bond. Okay, what type of bond has a big difference in electronegativity? Ionic bond. What kind of bond has a small difference? Covalent bond. What kind of bond transfers electrons? Ionic bond. What shares electrons? Covalent. And they're shared evenly, but in one direction only between the two atoms. What has the highest boiling points? Ionic bond. What's soluble in water with a high electronegativity difference? Is ionic. What's soluble in water with a low electronegativity difference? Is covalent, making polar molecules. And then what has mobile electrons shared by all cations around is metallic. Okay, so we'll keep working on props. But to review, we need a little review music. So, hello, I'm an acid. I start with hydrogen, and once you recognize, then you're ready to write the names and formulas. Right. Metallic bonding model explains properties of metals like shiny, luster, conductors. Memorize your ions, peeps. Don't forget. Metals have valence electrons. It's a valence electron C that describes the properties. Okay. Covalent bonding is sharing electrons evenly or unevenly between stuck-in-place atoms. Okay. Ionic bond transfer from cation to anion. Well, if you want to know what type of bond is present, look at the props. Look at the electronegativity. Look at the types of atoms. And then have evidence to back up your claims. Right? Nothing like a little Metallica to take us out. Right? Please read that section and these pages. And enjoy the knowledge of knowing if you know these objectives. Alright? See you soon.